Okay, so now we're going to learn a shortcut for long division, which is called synthetic division. Okay, we use this when we're dividing a polynomial, so something that looks like this, by x minus a. Okay, this statement right here has two pieces of information for you. Okay, the thing that you're dividing into your polynomial, over here it's x plus 5, has to have what I call a naked x. None of these will work. It has to be just like a 1 there, which we don't bother writing, remember? Okay, and the second thing about it is that there's something going on with the sign right here. Okay, so that's the main thing that you have to remember, is that there's going to be a change in this sign. It's not that you have to divide in negative things or anything like that. It's that there's going to be a sign thing. Okay, so now let's just remove this. Okay, so say we have a polynomial like this, where this is x cubed, and this is an x squared, this is an x to the 1, so see we're going 3, 2, 1, 0. Okay, so we have every single term, we have no missing terms, so if I write, instead of this expression, 1, 8, 17, and 10, then you should be able to recreate this. If you know I'm talking about a polynomial, if we agree that there's no missing terms allowed, then you should be able to write this back as that. What you'll do is you'll say to yourself, well, this is the n term, so it has no x's on it at all. This is the next highest term, so it will have just a single x. And this is the next highest term, so it will have a x squared. And you'll just keep adding an x as you go up. And this next term would be x cubed. So you can recreate the original from this. So we understand what we're talking about. Okay. So this guy represents that. This line right here represents the fact that this is what we're dividing into, and on this side we put what we're going to divide into it. So now here's where this negative sign sort of comes into play. Instead of putting a plus 5, I switch the sign. So I'm going to switch the sign. And I'm going to do a bit of shortcut. I'm not going to bother writing or representing the x part because we know that there's just a 1x hanging out there. I'm just going to put in the part that we don't know, which is what is that number. So I switch the number sign and I write it right there. Okay. Now if you need to recreate this to see what's going on, this means that there's an x and the opposite of this plus 5 being divided into this here. Okay. So the synthetic division is in green and the long division is in blue. Excellent. That's how we translate from here to here. So I don't know, let's just do one more example. So first of all, we need to represent our polynomial, and you might notice, it has a missing term. It has no x cubes. Okay, so that's exactly what we have to insert right there, is a 0. So it's got 1 here, 1 x to the 5, minus 3 x to the 4. It's got 0 x cubes. It's got 1 x squared, and minus 1 for the x, and its end term is 5. Okay, so let's recreate 5. This is the x's, so minus x, 2, 3, 4, 5, 6 terms for fifth order, 1, 2, 3, 4 terms for third order. So there's always one more number than the degree. So there's 4 for 3. There's 6 for 5, because this last number has no x's. Okay, nice. Get it? Oh, right, and what would we write over here? Before we go, we would take this, and we wouldn't bother writing the x, so we're just going to write the 3, and we're going to change its sign like that. So that's translating from long division to synthetic division. Now,